Wow. 1 second into starting the stream. Come on.
I'm on my own, broken alone. I feel the rain crashing down all around this empty town. I'm searching for the lost and found, but you don't care, you're unaware. Keep moving like the scars aren't even there. It's in the air like a blazing flare. Don't stare 'cause the flames will burn us. I thought you were the one for me. That's why I gave you everything. Held you close by the stormy seas. Oh, you meant the world to me. I used to kiss your head when you cried for me. Hold your hand while the pain was over. Keep you warm by the roaring sea.
I thought I could. Alright, this map is a lot bigger, I think, than it needs to be.
Because I believe the home was just you and me. I thought you were the one for me. That's why I gave you everything.
It would be cooler to do procedural generation on this, but
no point in blaming you, you did not know. Oh, I thought you were the one for me. That's why I gave you everything. Held you close by the stormy seas. Oh, you meant the world to me. Oh, you meant the world
Chad Zanani. What up, Chad Zanani? Oh. How we doing? How we doing? Height. Radius like 10. Position. Okay. Can I ask you a question? Sure, Chad Zanani. What you got? On area. I want. Definitely not at the point where I'm looking for art yet. I haven't even really figured out what this is gonna be, so unfortunately right now the answer is no. Oh fuck. No, this is right. It's 0. This one. Play from here. Sorry, gut, you respond late? Okay, yeah, don't worry about it. Oh, I meant to select 15. Cool. Appreciate you sending it through. Yeah, should be good.
story's over now, I must conclude. I am conflicted, watching where I step still, hanging in the balance, not the life I want to live. I want
Spawn area 2
fear, I weighed the
will be up here.
breakout I've got to see. Spent all my life holding all of it closely. I played it in a sense, a feel of discontent. I'm finally facing it all, fearless.
A third 2 Pyar. It's not exactly what I want.
Here we go.
Calculador. What was it? Square root of 3. 866,025. Yeah, that's where I want it. No. Do I figure out procedural generation? Because this is gonna be a mother. Or I can paint. Alright, maybe I do figure out how to do that. Go dot. This is exactly what I want. Although it's Godot 3. I don't know why my computer's running so slow right now. Skip. Oh, is this 2D?
Welcome to a new Godot 3 game development series. In this series, we'll be talking about procedural content generation, or PCG, sometimes also called ProcGen. I'll be explaining and demonstrating some of the most common PCG algorithms and showing you how you can use them in your games. The first PCG topic we'll be looking at is mazes. For this part, we'll be using the recursive backtracker algorithm, which you can see an example of running here. This is also known as depth first search. And what it does is explore the whole area and carve out a maze as it goes. And it's one of the easier maze algorithms to implement, so it's a good one to start with. And so what it's based on is a grid. So we have a grid of squares. Restart it again here. We have a grid of squares, and the algorithm explores the grid by cell connecting them as it goes, but never crossing over itself. In mathematical terms, this is what's called a spanning tree. And this means that there's no loops and there's only one path from any one point to another. But every 2 points on the graph are connected. So there's always a route between point A and point B, and only one route. And that's the recursive backtracker algorithm. Here's an overview of how the backtracker algorithm works. So we start by picking a starting cell. It could be anywhere on the grid. And we mark it as having been visited. And then if any neighbors of that cell have not been visited, then we want to pick one of them randomly and remove the wall between them, add the current cell, the one we started with, to the stack, and make the random chosen neighbor the current cell. And we mark that visited. And then if there aren't any unvisited neighbors, then we take the top cell from the stack and make it current. And we just keep doing that over and over from step 2 until there's no more unvisited cells in the whole grid. Now, if that doesn't make sense to you yet, don't worry. We will talk about what we mean by stack and what we mean by the walls between the cells. But this is the steps that it takes to make the maze, and this is the code we're going to write to generate our maze in Godot. Now, the first step whenever you're doing any kind of procedural generation is to figure out how you're going to represent your data. Now, since we're using Godot and we want a square grid, Godot has a tile map node built into it that's perfect for this. It's designed to handle a grid of squares. What we have to decide is how to represent the walls between the different nodes. And so here's a picture of a cell. This is one cell in the grid, and the cell has 4 walls. Each of those 4 walls can either be solid or it can be open. And we're going to, if we use binary representation for that, then we could say the wall, if it has a 1, it is solid, and if it has a 0, it's open. So that means that with any combination of 4 zeros and 1s, we could represent what state the cell is in, which walls are solid and which walls are open. So if we use a single bit to represent each wall's state, then a 4-bit number is going to represent the entire cell's state. And it would look something like this. Now, we could represent these in whatever order we like, but I'm just going to use the order west, south, east, north. So the rightmost digit is going to represent the north wall, and that's the 1's place. The east wall is the 2's place. The south wall is the 4's place, and the west wall is the 8's place. And so now any 4-bit number is going to represent any possible arrangement of these walls, and that will be a number between 0 and 15. And every possible tile, if we lay them out, is going to look like this. So these are all the possible combinations of tiles, and that number in the center is what binary number represents that cell. If you get a tile set, a set of images with 16 tiles representing these 16 combinations, you can use that tile set to represent your maze. And so for this project, I've selected Kenny's Road Textures pack. And if we make these into a tile set in Godot with the tile ID matching the wall pattern that you see here on the screen, we can use the tile map data to record our maze data as well. So whichever tile ID is in a particular cell, say for example if it's number 9, then we know that the east and south walls are open. So this is really nice because it means we won't need a separate data structure to store information about our walls. We can just use the tile ID in our tile map. So if you download the starting project, you'll get a scene containing a tile map with the tile set.
Okay, so I do need to use grid map.
Attached, containing all of the road tiles that we just looked at. Okay, so let's attach a script, and we're going to start by defining some properties. Firstly, I have the 4 direction values, the north, east, south, and west, like we looked at in the picture, and their binary values for what place they represent. And just naming them N, E, S, and W is going to make it a little easier to refer to them in code, so that down below, if we put the number 8, well, why is the 8 there? Well, we're talking about the west wall. We'll just use a W. And then this dictionary here, cell walls, is a mapping between those 4 values and what direction they represent, what actual physical direction on the grid.
All right, this is solid.
So
I'm going to save this. Subscribe there too. Save. And I'm going to open up the other one. Computer's so slow.
Imagine being able to build an app with your name on it, just by thinking about it. Meet Base 44, a complete AI creation platform. Describe what you want, and watch it take shape. You can plan, customize, and expand in any direction. From tools built for one, to platforms ready for many. From passion projects to enterprise-grade systems. Everything is built in and ready to launch. It's a new world of creation, where you can go as far as your imagination takes you. Can you imagine it? Let's make your dream a reality, right now.
My work is easy because I use ClickUp. Here's how I keep track of all my tasks. I start by brain dumping everything I need to get done in a list view. Next, I set a priority and a due date to keep things on track. I create custom statuses to organize my progress exactly how I want it. I like to add the action items field so AI can show me the next steps. I add my teammates as watchers so they're in the loop. ClickUp makes work easy, from personal projects to running a multi-billion-dollar company. Click the link below to create your workspace for free.
Hi, I'm Colin. I'm a high school computer science and digital media teacher, and for 13 years I ran and managed creative technology computer summer camps for middle schoolers and a little younger, teaching animation, coding, 3D modeling, and video game design. In this course, I'll be introducing you to the world of game dev by creating your very own, small, 3D platformer video game using two pieces of software, primarily Godot, a free and open source game engine where you can build and code your own video games, and Blender, a free and open source 3D creation suite for modeling, texturing, and animating 3D models for your games. This course is meant for the absolute beginner. If I can teach this to middle schoolers, well, I can teach it to you. Now, if you already have even a little experience using Blender, you'll be able to take this project even further. Otherwise, I'll be guiding you step by step through each phase of building and programming this project, including creating a new project in Godot and starting a game level, adding a camera and a light into the game level, and we'll add a simple character object. We'll start with a cube, programmed to move by pressing the arrow keys on the keyboard. We'll be breaking down and covering what I consider to be the top 8 programming concepts beginner programmers need to know to get started coding, as we customize the movement of our character using code, create collectible objects, coins that disappear when you collide with them, make your character jump and tilt to align with the floor that he's standing on, make the camera follow and be able to rotate around the character, create keyframed animations and trigger them to switch and play with code. We're going to create enemies that turn around at walls and edges. We're going to make moving platforms using tweens, a heads-up display on screen to show how many coins have been collected, menu screens with text, images, and coded buttons. And because this is a 3D game, we'll be using Blender to create a few of our own custom game assets, including a coin model, as well as textured blocks that we can easily use to construct our game level. Lastly, we'll finish this project off by exporting to a standalone Windows program, as well as publishing our game to a popular indie website, itch.io, where our game will be playable right in the web browser. For this course, I'll be providing you with all the assets you'll need to complete this project right alongside me. I can't wait for you to join me in creating this 3D platformer game and entering the world of game dev. To get started, you'll need to install both Godot and Blender. If you're using a laptop, I also highly recommend having a wheel mouse rather than having a trackpad or something else. I recommend getting both programs from the official sources. Godot from godotengine.org. We'll go up to downloads here and I recommend getting the latest version, at least 4.0. I'm going to download the Windows standard 64-bit version, as that's what will work best with my computer, and it's a surprisingly small download at just about 51 megabytes. It's a zip file downloaded here to my downloads folder, which I need to unzip. So in Windows, I'll right-click on it, and I'll say extract all.
Okay.
Now, Godot is a
This
bit of a
is
funny
not-
program in that
Coding. A coin model, adding materials in sky, smooth camera follow, modeling world blocks. I think it's this one. We got salad, tan 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 tan. Honey.
Welcome this to SportsCenter.
We've got the answers.
Plenty of reason to celebrate.
We're getting you ready. This is not hyperbole for the best matchup of the season.
Get a good look. We'll see you later.
No skip. Kena dulu. Skip.
all right, as it stands, our project is going pretty well, but it's at this point in the project where we need to start thinking about building out our game level. After all, this is a platformer game, so in this lesson and in the next lesson, we're going to go from what we have right now, which is basically just one simple square platform, into this. This is what we're going to have at the end of the next lesson, in which we're going to create some custom blocks in Blender, including some texturing work, and we're going to use those blocks as what's called a mesh library of blocks that we can paint into our game level using what's called a grid map in Godot. So after the next couple of lessons, we'll have made all these blocks and we'll have essentially just painted them into our 3D world, which is super fun, and it makes it really quick and easy to design a game level just like this. So let's go ahead and jump in. In this lesson, what we'll be doing is going into Blender and 3D modeling our 7 custom blocks for our game level. We'll also be doing texturing, including using what are called UV maps as well as normal maps to create that bumpy texture on the top of all of our game blocks. And in Blender, we'll also be defining simpler collision shape versions of all of our blocks so our character can collide with a simpler shape, which will optimize our game. Lastly, in this lesson, we'll export our blocks from Blender into another GLTF file. So let's go ahead and jump in. In this lesson, we're not going to do much in Godot, so I'll press Control S on my keyboard and then switch on over into Blender. The blocks in our game level are going to be basically built off of a simple cube, but I'm not going to use the default cube because the default cube that starts with you when you open up a new Blender file comes with a material. So let's go ahead and delete this cube. I'll press the letter X on my keyboard right away to delete that cube, and I'll go up to the add menu and add a mesh cube. I'm going to take that cube and I'm going to name it right away. It's important that we do our naming quite precisely in this lesson because it will actually matter when it comes to exporting this into a GLTF file, that Godot knows what to do with the different objects. Trust me, naming is key in this lesson. So I'm going to go up to the outliner in Blender where I have my cube, and I'm going to name my cube simply by double clicking on its name, block. This is going to be my generic square 2 meter by 2 meter by 2 meter block. However, I'm going to take this block and I'm going to bevel the edges. The edges are a little bit diagonal on all of the sides. So I'm actually not going to use the bevel tool in edit mode in Blender. Normally I would go up into edit mode and then go into edge select mode in edit mode and then select an edge, or actually I'll press A to select all of the edges, and then I would go down to the bevel tool and then pull out all of the edges just a little bit to bevel them. However, there is an easier way. If I undo that, Control Z, and then I go back into object mode, I can simply select a mesh, go over to the properties editor and down to the wrench tab where we can add a modifier. A modifier in Blender is a way you can quickly add a procedure.
This is crazy. Why is my computer so slow right now? I download some malware?
Mode, I can simply select a mesh, go over to the properties editor and down to the wrench tab where we can add a modifier. A modifier in Blender is a way you can quickly add a procedural change to a mesh object. In this case, if I go to add modifier with my cube selected and I add a bevel modifier. Hello, it's Future Colin here with a quick update for you if you're using a newer version of Blender. If you're using Blender 4.0 or later, you'll notice that when you go down to the wrench tab and then go to add modifier with a mesh object selected, well, when you click add modifier, you no longer get a nice big spread out menu of all the different modifiers you can add. Instead, they've separated out all the modifiers into these sub menus with categories. So there is the edit category, generate, deform, and physics. These line up almost perfectly with the categories that were at the top of the old big menu, but now you can find the bevel modifier, as we're using right now in this lesson, under generate and bevel. Okay, there it is. It will bevel all of the edges in the mesh essentially all at once. So what I'll do here, and one of the reasons why I'm using this modifier instead of doing the beveling manually in edit mode on all of the edges, is I can really quickly perform the action of beveling, but also change the amount very easily over here. So I don't like this amount quite so much. I think it's a little bit too big for my purposes here. So I'm going to change the amount to 0.08. and press enter. One of the nice things in Blender is that when you set this value up once and then you add the bevel modifier to other meshes, it will remember that value, which is nice. So I've got my block shape. However, in Godot, we don't want the collision shape for this block to have these little beveled edges. That would make collision detection much trickier for Godot. In fact, when we start making our character actually look like a little robot, and when it's actually moving over the ground and going up ramps and transitioning between different blocks, we don't want to confuse Godot for when it passes over an edge between two blocks, because we don't want it to think that the character is not on a floor, and it might not if it thinks it's right over a diagonal edge. So what we're going to do in Blender is make a second simpler shape for each one of the blocks that doesn't have these beveled edges and is simpler and has fewer polygons. So I'm going to go up.
Don't give me an ad. Diabetes.
Coronary disease,
autoimmune diseases,
obesity, cancer.
Pretty much all chronic diseases of the Western world are associated with the gut microbiome that is
polygons. So I'm going to go up to the add menu right away and go to mesh cube, and this simple cube with no changes is going to be the collision shape for my normal block. What am I going to name this secondary block? Well, I have to name it something very specific in order for Godot to understand what to do with it when it brings it in. If you name what will be your collision shape...
No way. No way you're hitting me with another ad right now.
A very specific name, which is the same name as your actual block, the way it's going to look. So I'm going to type here block, but then you put a dash, which is a minus sign, and then you type COL, all lowercase, for collision, and then you type the word only, so collision only, and then press enter with no spaces in it. So the same name, block with a capital B, and then dash, and then COLONLY. It looks like colon. It has nothing to do with your colon. Trust me, it stands for collision only.
Colon.
That's what it has to be named. You also need to make this collision version of your block a child of the actual block. So what I'm going to do here is hold Shift on my keyboard in my outliner. if I hold shift and then drag the collision only version of the block onto the block and let go while still holding shift, it will disappear from my list, because now if I expand out the block, the original block, you'll see that the collision only version of the block is a child of the block. And therefore, if I select the block, the one that has little beveled edges, and I move it, its child, the collision only version of the block, will move along with it. So it's a child. What we're going to do here is give our actual block the materials. Before we do that though, I'm going to select the actual block and we're going to apply that bevel modifier. We want those extra edges to be permanent. So I'm going to go to the wrench tab, and on this little arrow here, I'm going to say apply to the bevel modifier, and that will make all of its edges permanent. So now if I hide my collision bevel modifier, to the wrench tab, and on this little arrow here, I'm going to say apply to the bevel modifier, and that will make all of its edges permanent. So now if I hide my collision only block, which I don't need to see anymore until later on in this lesson, you'll see how the block will actually look. And I can go down to the material tab in Blender, press new to make a new material, and then I can change the base color to whatever color I want it to be. I'm going to make my blocks kind of a purpley bluey color, kind of like that. So if I click off of the color picker, you'll see what that color looks like. I won't see that color in my 3D viewport until I go up to the viewport shading.
A lot of downtime here.
Salah, Mo Salah.
I won't be so good at this. I'm one of them. Why can't be single, man? I can't be single, bro. Harley likes my muscle, bro.
Your English is very good. How long did it take you to learn English once you got it?
It was really easy because we.
Is this working or what? We crashed? Please, please, please load for me. Okay, what's going on here? Hello, Blender, hello. This might be a full reset here.